We got another story here. NVIDIA and others are looking to make CPUs for Windows. Talk to me.
Yeah, all right, let's bring it back to the world of technology.
Mm-hmm.
So recently there's been a couple of interesting things happening in the CPU space. So ARM-based CPUs, which are different to x86-based CPUs, so like the M3 chip, Apple's M3 chip is ARM-based. ARM is a company that creates a type of CPU technology, and they just license it out to people. NVIDIA was looking to acquire them a few years ago. That fell through. They're going to acquire them for like 40 billion or something like that.
Jeez.
So there is obviously like a lot of focus on ARM-based CPUs. So you got AMD, Qualcomm making these CPU designs. But the interesting thing is that NVIDIA is also jumping into the mix. They're going to make their own CPUs that will be able to run on, or they'll be compatible with Windows PCs, or they're designing ARM-based CPUs for Windows PCs that could arrive as soon as 2025.
Wow, it's around the corner.
Yeah. And
What?
so we've seen the absolute high end of what this could be, which is the Grace Hopper super chip.
Yep.
NVIDIA's, ridiculously expensive AI supercomputer chip. So the Grace part of that is the CPU. That's an ARM-based CPU, and then the Hopper side is the GPU. And it's designed for AI. So most likely, what they're doing here is designing CPUs for Windows workstations, right? So these will be like high-end PCs that will run Windows that most likely be used for AI stuff and productivity things. And so they would have basically be kitted out with a NVIDIA CPU, one of these new CPUs, and one of their workstation GPUs, like the A4000s or whatever they're called. So it is pretty kind of cool. The weird thing is that obviously, not a weird thing, but like one of the funny things is that during Intel's latest earnings call with investors, somebody asked the CEO about, NVIDIA, AMD, Qualcomm, all making these new or developing ARM-based CPUs, and they're going to be, for Windows PCs, which obviously, as we know, that's where Intel's bread and butter sits.
Oh, of course.
When it comes to workstations and servers and things like that. So Pat Gelsinger is the Intel CEO, and his response is that ARM and Windows client alternatives, they've been relegated to pretty insignificant roles in the PC business. We take all our competition seriously, but I think history is our guide here. We don't see these as potentially being all that significant overall.
Just
so he's
wait,
basically
mate.
Just
wait.
He's like meh. Like one of the hurdles is that an ARM-based CPU needs to emulate x86 architecture or Windows stuff. But the thing is, Microsoft is investing heavily into ARM as well. So they could be just, optimizing Windows for ARM CPUs. And if AMD and NVIDIA are on board, I would say, and Qualcomm, I would say it's more than insignificant.
That's why I said just wait. That's something that, I don't know, it kind of speaks to two different things. It's either like Intel is that confident that they're almost arrogant, or
they just don't want to show their.
They're scared.
You don't want to see them sweat. Yeah,
it's one or the other. It's one or the other, because that response is quite binary there. It's like we take all of our competition seriously, but I think our history is our guide here. We don't see these as potentially being all that significant overall.
Yeah,
either you're short-sighted or you're just like, meh. What are they going to do?
And there's a little bit of contradiction too, because Intel is investing heavily in foundries, so they're looking to take on TSMC and Samsung when it comes to creating their own CPU, their own chips, not only for themselves but for other people. So Intel, they have a long history with foundries and creating their own, their own chips. But as of now, the Apple M3 chip that we spoke about earlier, that's using TSMC 3 nanometer process technology, which is the absolute cutting edge of the cutting edge.
Yeah.
In terms of GPUs, the 40 series from NVIDIA is using TSMC 4 nanometer, like a custom 4 nanometer node. And that's currently the most cutting edge GPU process or chip technology available now. And so Intel is looking to create, like their own like advanced process nodes, and they want other customers to like NVIDIA to like say, hey, we want you to make the chips for our next XXX. So, on one hand, Intel is saying, yeah, this is going to be insignificant. Then on the other hand, they add, thinking about, alternative architectures like ARM, Pat Gelsinger adds, we also say, wow, what a great opportunity for our foundry business. So if these companies are making ARM-based CPUs, then it's going to be awesome for our foundry business because we'll be able to produce them. But it's like, I thought it's contradicting because if they're not significant, why is that great?
But we want to make them.
Yeah.
What?
It's yeah.
This is bizarre.
So it's a weird sort of like little response.
Is that just like a corporate contradiction?
Yeah. But it's like selling. Yeah, it's
like on one side the corporate face is like, yeah, I mean, don't worry about these ARM chips. Oh, the other people are making. Don't worry about them. Yeah. But this will be healthy. We'll be able to make them.
Yeah, all these ARM chips is going to be really good for our brand new factory over here that makes chips.
Okay, Intel. You're excited, but don't be excited.
Yeah.
All right.
I think the one question though is that this raises is that will we see a future where you could buy a gaming PC that has like, a 6090 or a 7090 or a 5090 or 50 series GPU with an NVIDIA ARM-based CPU. Will NVIDIA get to that point? Will they be able to get it running on Windows and with working with Microsoft or whatever the case is in terms of working with their GPUs? But like, will they be able to then create like use AI stuff with the CPU and GPU? Like, would they make a play for the actual consumer CPU market?
I think they will. I think it's only a matter of time. Like, why wouldn't they? They've got such a lead in GPUs over AMD. AMD survives because of its CPUs. It's not because of its GPUs. I can imagine some incredible, and I think we've spoken about this on the show previously. I can't remember the episode, but I think we were talking about if AMD released some magical tech that was kind of like, for all intents and purposes, Infinity Fabric between the CPU and the GPU, and it would give you X boost in performance.
Yeah.
So
yes,
like,
that's right. We were talking about that.
Yeah, I can't remember what episode it was, but imagine if NVIDIA did something like that. Like if you wanted to go green and you were even, let's say, a pre-built desktop computer with this specific configuration with the 4070 or 5070 paired with an NVIDIA ARM chip, you now get 25% boost in performance in-game in every single game. Why would you not, as a gamer? Everyone's already running NVIDIA chips, NVIDIA graphics cards.
Yeah.
You may as well go. You may as well go and
80%
get the NVIDIA ARM CPU. I would.
Yeah, and they could integrate graphics on it. Like they could just put like low level, like it'd be like pretty exciting. Because also as well, like I think you might be right as well, because if you look at like AMD, like their biggest success recently has been with their mobile processors that have APU functionality. So they're like the stuff that's in the Steam Deck and the ROG Ally that has powerful CPU architecture as well as like GPUs, integrated into the CPU. And that's something that like NVIDIA can't really do because they don't make CPUs, right? So either you're going to put their mobile GPU in your handheld device or you're not. And most people aren't, because like it comes down to power usage, right? So if the new that Ryzen, the Phoenix architecture, which is really, really good in the ROG Ally and the new Lenovo Legion, as well as like, the older versions of that sort of technology in the Steam Deck, it's proving to be like pretty popular because you're getting like low power usage but really good performance for gaming. And that's a sector that NVIDIA can't really, or doesn't really have anything that slots in.
Yeah, it's strange.
Unless they make their own CPU.
Yeah, it's strange. Intel are making GPUs now with the Arc, predominantly CPU business. Now, NVIDIA, predominantly GPUs, is now pushing towards CPUs. AMD has done both for how long?
Ages, yeah. Well, since like the days of like Athlon and other old school CPUs and was it ATI cards and things like that.
Everyone's making each other's stuff, which is what I like. I mean, it's all great for the consumer because competition is going to drive these prices down. And it's also going, like, we're kind of at the stage where the performance is so good across almost any configuration of PC hardware. It's almost like you can achieve 1080p 60, which is like bare minimum for gaming, with something that's relatively cheap. And so what we're going to see throughout more products from different competing brands coming out is technology such as DLSS and all of these things that you'll probably end up going green for NVIDIA Remix or something like that. Like, that's why, because the performance is already there if at the bare minimum state of gaming. Like, if you're a real budget gamer, but you will still get all of these cool tech or all of these cool technologies that come with it. I think it's going to start to go towards that kind of way because 1080p
like
60 is, I mean, it's garbage for me because I've run 240 hertz at 1440p and 4K and stuff like that. But budget gamers, I think like we're already at 1080p 60. We're moving into 1440p at like the budget level of PC components. So I think we'll see more technologies to attract gamers to buy certain brands. It's a bit gatekeepy, kind of stinks a little bit, but
yeah, it is gatekeepy. But I mean,
why else would you go? Like we're already at the performance level for it. It's like why else would I upgrade ever then?
Exactly, and like I mean, like the proof is in like the
pudding
in the results, right? So like AMD's FSR 2 and 3 is open source, so it works on all GPUs. They develop their algorithm not to be dependent on AI hardware or proprietary hardware or whatever the case is. And DLSS, obviously, it was introduced in the 20 series, requires tensor cores. And but the thing is now is that there's been 3 generations of the RTX cards. So now the majority of GeForce cards out there are RTX cards. So it's no longer as gatekeepy within NVIDIA. So that sort of has died down the conversation. But the end result is DLSS looks better.
Of course.
FSR looks good, but DLSS looks better. And one of the reasons for that is maybe because like it's proprietary hardware and proprietary tech.
That's exactly right.
If you look at Intel, they do a mix, right? Intel XeSS uses AI hardware where you enable it on an Intel card. And when you enable it on a non-Intel card, it uses a separate algorithm for temporal for its upscaling. And it doesn't look as good as the version when you're running it on an Intel card.
Yeah.
And that kind of like proves the point where it's like, well, yeah, like if you're developing your tech for your own AI hardware or your own proprietary hardware, then it's just going to look better.
Yeah. Yeah. Well, Apple is the epitome of that. It's like you can't even customize their stuff, but that's how they get such good performance out of it, especially in terms of like battery life, heating, cooling, the form factor, all of it. It's like they don't let you change a single thing. And if you want to add anything to it, it costs you $300. And they have to do it. And if you even try and do it, you void warranty. Unless you go to an Apple store, of course. But yeah, they're a company that has famously moved away from customization or letting consumers customize their products. But through doing that, they can squeeze every last bit of performance out of it and optimize their applications for that specific configuration of hardware.
That's why consoles are, like, they always punch above their weight visually.
Yeah, absolutely, yeah.
That's why, like, because the Nintendo Switch, the original Switch, all right, sure, games look dated now, and it's creaking and cracking under the pressure, but I mean, the thing has a version of The Witcher 3 running on it, and Doom Eternal and things like that. But this is like hardware from 2013, and like it was when NVIDIA showcased their Tegra chip, it was running Doom 3, right? Doom 3 is a game from 2006 or 7.
Oh, 6.
Doom.
I was thinking 2016. Sorry.
Not even 2016 Doom.
Yeah.
So then, when that chip was in the Switch and people got actually 2016 Doom running on it, people were like, "What? How? Why? How did you do this?"
Impressive.
Because you're optimizing for that specific configuration.
And I think through that, and just to bring it back to the NVIDIA ARM CPUs, it's evident that if you have a select configuration of hardware, that you can optimize your software much more efficiently and get much more out of it. So with that being said, I think it's almost a no-brainer that NVIDIA will roll out its own CPUs, offer extra performance when they're paired with the NVIDIA GPUs. Yep. I think that is an obvious step. If I was NVIDIA, that's what I would be pushing for. That would, and if you do that and you offer, let's say the performance increase is like 35% across every game, like it is hands down shocking. You will now be dictating the CPU market as well, and you're going to squeeze AMD and Intel to the point where they're going to have to release their own software that does the same thing.
Yeah.
Because
it's also like,
why would you ever run a mismatch if that's the case?
Yeah, I know.
It's like a right, someone cut that. It's like a set bonus in like an RPG. It's like when I've got the entire hat, like pets and robe on and shoes, I get a 40% damage increase.
That's the best way to summarize it.
There we go. All right.